The following asks us to solve the quadratic equation by graphing. We're familiar with graphing quadratic equations. They turn out to be parabolas. But usually when we graph them, we have y equals this instead of equal to 0. Well, the reason we can do this, what we're going to do, is because our goal is to find out when does y equal 0. Well, y equals 0 at a very specific time, and that is at the x-intercepts. Okay, so whenever y equals 0 on a graph, the y-coordinate is 0, and the y-coordinate is 0 on the x-axis, or the x-intercept. So what we're going to do is we're going to plug y in for 0, graph it, like we know how to do, and then decide what are those x-intercepts. What are the x-coordinates and x-intercepts, and that's our solution. That tells us what the value of x is when equals 0. So we're going to graph it using the negative b over 2a. Remember, a is in front of the x squared, b is in front of the negative 4. This allows us to find the x-coordinate of the vertex. Vertex meaning the point at the bottom or the top of the parabola. So in this case, it's going to be a negative 4 over 2 times 1, which is 2. And a negative 4 becomes a positive 4, so you end up with 4 over 2, which equals 2. Then we fill in the t-chart, fill in our x values. The vertex is 2, so we put that in the middle. And then we're going to count up and down from 2, both directions. So counting up, we go 2, 3, 4. Counting down, we go 2, 1, 0. Usually, when you graph, you got to decide where to start. A lot of times a good place to start is a vertex, or you can start down at the bottom with a 0. 0 is always really good to use. In this case, I just went ahead and did the vertex first. So I put in 2 for x, and then go find out what y is. So 2 squared is 4, minus 4 times 2 is 8, plus 3. So you end up with 4 minus 8 plus 3, which is the same as negative 4 plus 3, or negative 1. So our vertex is 2, negative 1. But again, we're just looking for the graph here because what we really want are the x-intercepts, which is when y equals 0. So we're going to plug in 1 this time. I like to pick 1 just because it's a little bit easier to do than 3, smaller numbers, so you might as well use them. And so it doesn't matter because 1 and 3, the x value for 1 and 3 are going to come out with the same thing. So you put in 1, you get 1 squared minus 4 plus 3, which equals 0. Now that's interesting because that's what we're looking for, but we'll come back to that in a second. So that means 3 is also 0. When you plug in 3 for x, you get 0 for y. So now we're going to try 4 or 0. Well, 0 is always easier, so always pick 0 if you can. 0 squared minus 4 times 0 plus 3, and that gives you y equals 3. And so when you plug in 4, you would also get y equals 3. That's what happens. You plug in 3, plug in 1, you're going to get 0. Plug in 0, plug in 4, you're going to get 3. So now we go over and plot these points. 2, negative 1, 0, 3, 1, or 3, 0, 1, 0, 4, 3, and 0, 3, and you draw your graph. And again, if you remember, back to the beginning, what we were looking for is the x-intercepts. The x-intercepts because that is where y equals 0, which that was the whole goal of this problem, was to find out when does my quadratic equation equals 0, once we did the substitution and put y in for 0, that meant when did y equal 0. And if you notice, again, there are all these points. So it isn't always the case that you actually identify the points as directly. And so in this case, it was real easy. It's very specific. X equals 3, x equals 1. Sometimes you've got to estimate the answer, but in this case, we knew this very specific answers, and that is x equals 1, x equals 3.